And before we get to example 2, I want you to turn to the bottom of page 469, and we are going to get introduced to the unit circle. So what's going to happen is we are going to look at a circle with a radius of 1. This, oh, here we go. There we go. You can take out your highlighter on this page. Maybe take out your highlighter. And we can highlight what the unit circle is. So this is on page 469. At the bottom, there's a little circle. If you have a center at 0, 0 and a radius of 1, that makes the unit circle. And this is going to set us up for the big ideas of trigonometry in grade 12. So if I pick a random point on the unit circle and I draw and make a triangle back to the nearest x-axis, I will make a right angled triangle with its reference angle. And if I draw that triangle and I picked a random point with an x coordinate and a y coordinate, would you agree that this length is x and that length is y? Now from grade 10 math, we can write what is sine of the angle. So I'm going to call this my angle theta. There's my angle theta. Would you agree from that triangle that if you wrote out sine of theta, which is the opposite over the hypotenuse, my opposite side is y, my hypotenuse is 1. And if I write cos of theta, my adjacent side is x, my hypotenuse is 1. And you have space at the bottom of page 370. And at the bottom of page 370, we are going to write 3 big ideas for trigonometry that result from this simple idea of the unit circle. Big idea number 1 is if we do this, we notice that sine of theta is y and cos of theta is x. So instead of writing the point as x comma y, we can write the point as replace the x with cos, replace the y with sine. So big idea number 1 is that points on the unit circle are cos theta, comma, sine theta. Next, they tell us that the equation of a unit circle is x squared plus y squared equals 1. All this is the equation of a circle is just a squared plus b squared equals c squared. Because if I draw a triangle, when I draw this triangle back to the nearest x-axis, can you see that you make a right angle triangle where one side is x one side is y, and since my radius is 1, the hypotenuse is 1. Can you see then, if you did a squared plus b squared equals c squared, you would get x squared plus y squared equals 1 squared, or the equation of a circle is x squared plus y squared equals 1. Big idea number 2, though, says that if x is the same as cos and y is the same as sine of theta, then I can write the following. X squared would be cos squared, and when we square cos, there's new notation for you. We put the squared in between the cos and the theta. And y is sine, so y squared would be sine squared equals 1. On your formula sheet, they write it like this. Same thing. Sine squared plus cos squared is equal to 1. Pick an angle. Try it on your calculator. Right? Do bracket sine 12 degrees. On your calculator, you'd have to put sine in brackets and then square. And then I'm going to do plus cos of also 12 degrees. And square. Works out perfectly to 1. And it will be true no matter what angle you use. Cos of 33.2 degrees squared plus sine of 33.2 degrees squared will equal 1. But it only happens if the angle is the same. So the theta has to be the same for this to happen. This is big idea number 2. And big idea number 3 is if we look at that triangle, and we've done sine, and we've done cos, why don't we do tan? Tan is the opposite side, which is y, over the adjacent side, which is x. But if y is sine of theta, and x is cos of theta, then big idea number 3 is that tan of theta is always equal to sine of theta over cos of theta. And now we've just opened up a ton of mathematics that we can do with this little diagram, because now we can rethink of, instead of sine being opposite over hypotenuse, we can think of it, oh, it's just a point on a circle. So it's sort of like, what? I've changed trigonometry from triangles to circles? A little bit, which is a little bit mind-blowing. It's still triangles, because what are we actually doing when we're thinking about a point on the circle? We are still thinking about the reference angle and drawing a triangle to the nearest x-axis. But this explains a ton. This explains the cast rule. For example, pick a point in quadrant 2. Right? If you pick some point in quadrant 2, would you agree that your x-coordinate is going to be negative and your y-coordinate is going to be positive? If your y-coordinate is sine, this explains why, in the cast rule, only sine is positive. And if tan is y divided by x, sine divided by cos, a positive number divided by a negative number will be negative. And only sine will be positive. If we pick a point in quadrant 3, can you see that your x-coordinate would be negative, your y-coordinate would be negative? That means x is cos, it's negative. Y is sine, it's negative. But tangent is this divided by this, a negative divided by a negative. Tangent will be positive. And if you pick a point in quadrant 4, the x-coordinate is positive, the y-coordinate is negative, and only cos will be positive. So there's your cast rule, simply explained with the unit circle. And of course, if you did anything in quadrant 1, everything is positive. So they'll all be positive. So this simple diagram has huge applications for trigonometry. All right, well, let's go to example 2 now. We are actually going to skip 2a until after we have done our unit circle activity, where there are some values on the unit circle that you need to know and have memorized and figure out, and some that we'll be able to use our calculator for. So we are only going to do 2b right now. And in 2b it says, determine the approximate values of the 6 trig ratios. Oh, I missed. All right, before we get to 2b, we have to go back and do one more definition on the page before. You only know 3 trig ratios. You know sine, cos, and tangent. But there are 3 more, the reciprocal trig functions. There is secant, cosecant, and cotangent. Secant, cosecant, and cotangent. The secant ratio, what I'd like you to do right beside this is that secant is 1 over cos theta. And cosecant theta is 1 over sine theta. And cotangent theta is 1 over tan theta. And because tan theta, our big idea for tan theta is tan is sine over cos, that allows us to say that cotangent this could be a big idea. You could add this to the big idea number 3. If tangent is sine theta over cos theta, and cotangent is the reciprocal, reciprocals take fractions and flip them, right? Remember doing the negative reciprocal for slopes of perpendicular lines, where you found the slope by flipping the fraction and making it negative? So then cotangent is 1 over tan, and that also means that cotangent is cos over sine. So then in 2b, it says, write out the 6 trig ratios for 586 degrees. So the primary ones would be figuring out sine, cos, and tan. And I'm going to get you to take out your calculators. And then we want to find out cosecant, secant, and cotangent. So first of all, I want everybody to type in sine of 586. And I want to make sure that you see that it's equal to negative 0.719. If you got 0.995 on your calculator is not set in degrees. So that's the first thing we want to check, is that make sure our calculators are set in degrees. And then we can figure out the rest of these. We can quickly figure out what cos of 586 is. Negative 0.695. And tan of 586 degrees, 1.035. Now you don't have a cosecant button on your calculator, but what we're going to do then is we are going to type in 1 over sine of 586 negative 1.390 1 over cos be negative 1.440 and 1 over tan is 0.966. So I rounded to 3 decimal places because the question said to round to the nearest thousand. Only one to circle is 7b right now. Again, we will do 2a after we're done our unit circle. Now, if I asked you what quadrant is 586 degrees in, is it in quadrant 1, quadrant 2, quadrant 3, or quadrant 4? Again, a little review, a reminder. This is quadrant 1, this is quadrant 2, this is quadrant 3, and that is quadrant 4. So where's 586? Okay, a couple of ways you could do this. Okay, maybe you've got in your head, if you came up with quadrant 3, you are correct. A couple of ways you could do this. You could find something coterminal with 586. I could subtract 360 degrees. If I subtract 360 degrees, 586 is coterminal with 226 degrees. And then you would think, okay, well, this is 90 degrees, 180 degrees, 270 degrees, 360 degrees. If I subtract 360 and I get 226, well, 226 is somewhere between 180 and 270. It's in quadrant 3. That would be one way to do it. You could also use your CAST rule to figure out this is in quadrant 3. Notice, when you did sine, cos, and tan, that only tangent was positive. According to your CAST rule, what quadrant is that? Quadrant 3. Right? Because if I add my CAST rule here, wow. Here we go. If I add my CAST rule here, then I'd see in quadrant 3 that tangent is the only one that is. And my result said that as well. Some other things I want you to notice. Does it make sense that if sine is negative, its reciprocal, cosecant, would also be negative? And that where cos is negative, secant will be negative. And if tangent is positive, cotangent will be positive. So these are some patterns that start to come up that we have to be able to recognize.